Hi, good morning students. Welcome back for session number 1, chapter number 3. So in previous 2 chapters, we discussed about some basics concepts of computer as well as computer configurations, and also how the input and output devices are classified, what are all the functions of all the input and output devices, and also we discussed about some memory devices also. So in that 2 chapters we learned these basic concepts about computer and also some input and output devices. So today the new chapter name is data representation. So in this chapter we are going to learn about the numbering systems, how the computer will store the memory. In the previous class I given some hint about how the memories are bifurcations, how the memories are classified, what is a bit, what is byte, what is the present memory capacity of the computer. All these basic concepts we discussed in the previous chapter itself. But in this session we are going to learn about data representation. So before going to the introduction, one common thing I want to tell you, that is, in the data representation, storage of the data in the types of bits and bytes. Okay, the bits and bytes are the types of the memory storage computer, but how we will coming to know what is the capacity, how much for 1 GB is equals to 1024 megabytes, how we will calculate that? For that we need a representations of the numbering systems. We are using some mathematical functions to calculate all these memory devices and all as its capacity. That's why in this particular session number 1, we are going to discuss about these concepts. Types of the numbering system. If we are having any types in that positional and non-positional numbering system, what are all the sub-types of that particular numbering systems, where we will use and how we will use, all these concepts we are going to learn in this particular session, dear students. So directly without wasting time, if I coming to the introduction of this chapter, before going to the introduction, if I want to tell about the weightage of this chapter, that is, in this particular chapter you will get 1 3-mark question and 1 5-mark question. So total weightage of this chapter according to the blueprint of previously what we have, according to that one, that is 8 marks, dear students. So in this particular chapter you will get 1 3-mark question as well as 5-mark question. So now directly I will coming to the introduction of the chapter. So in this introduction of the chapter, we are able to learn the major 2 concepts. One is types of numbering system. Types of numbering systems. In the types of numbering system, again we are classified into 2 types. One is positional numbering system, and second one is non-positional numbering system. So out of these two types of the numbering system, we have individual definitions for these two types of the numbers. How we are able to define these two types of the numbering system? See, in this particular type of the numbering system, the positional numbering system has its base and power values. The example for the positional numbering system we are having, that is decimal, binary, octal and hexadecimal. Numbering systems we have in these types of positional numbering system. Later we will discuss how the decimal numbering system, how the binary numbering systems are numbering system for the calculation purpose we are using, how these numbers are calculated. Everything we'll discuss later, but particular part here we are coming to know what is a positional numbering system. This type of the numbering system has its own base and power values. For example, x to the power of n. Now the x will becomes the base and n will becomes the power. So like that, if any types of the numbering system has its own base and power, so that type of the numbering system is what we called as positional numbering system. Example, that is decimal, because is as its own base, that is a 10. Like that, binary has its own base 2, octal has its own base 8, then hexadecimal has its own base, that is 16. That's why the classifications of the numbering systems based on its power and bases, that type of the number is what we called as positional numbering system. Then we have one more category. That is what we called as non-positional numbering system. So, of course, as I said earlier, which numbering system has its base and power, that is what we called as positional numbering system. Then what do you mean by non-positional numbering system? So, if I want to explain non-positional numbering system, now I want to first take one number. See here, in a non-positional numbering system, now I will write one Roman number. See, 1, 2, like that, etc. Okay, 9, 10, right? Like that, we are using some types of the numbering system. For these types of the numbering system, there is no base, no power, or no base, no index like. So there is no base and power types of the number. So these kinds of the numbering system, but we have a number for this. For the calculation, we will call this a particular type of the number, that is a 1, 2, like that, this is 9 and 10. We have some numbers. Then in like that, if I want to continue, means that is m in Roman letter, that is 100 value. Like that, still we have so many numbers. But how we will classify? Based on which criteria these numbers are, we are telling that is a non-positional numbering system, because for these types of the numbers there is no positions. There is no position means there is no base number and there is no index numbers, or there is no power values. So that type of the numbering system is what we called as non-positional numbering system. The best example for non-positional numbering system is Roman numbers. Remember, Roman numbers. Sir, why? You can ask a question here. Sir, why these types of the Roman numbers are non-positional? As I said earlier, these numbers we are using for simply the index or for the calculation purpose, identification numbers or bifurcation numbers, but these types of the numbering system we are not at all using for the calculations. Like arithmetical numbering system, what we have, some 0 to 9. 0 to 9. In between these number, we are not at all using the Roman numbers that are what we call as natural numbers, but these are Roman numbers because we are using these number for the identification purpose, as well as that is this type doesn't have any base and power values. So the best example is Roman numbers. Like that we have some classification. So this is about in this chapter. Now you coming to know we have a types of numbering system. In that the first one is positional numbering system, second one is non-positional numbering system. So in the positional numbering system, the which number has its own base and power, that types of the numbering systems are called as positional numbering system. And which type of the numbering systems doesn't have any base and power values, that type of the numbering systems are called as non-positional numbering system. The best example for non-positional numbering system, that is Roman numbers. So this is about types of the numbering system in data representation. Now we will coming to know in here afterwards. Now we are going to discuss about some what is decimal numbers, what is binary, octal, hexadecimal. All these numbers now we are going to learn by its base and as well as power. So now you will coming to know how the classifications of the numbering systems are made. So dear students, after a numbering system, if I coming to the classifications of the positional numbering system, in that the first type of the numbering system is, that is positional numbering system subpart is, that is decimal numbering system. Usually you heard this word decimal. What is decimal? What are all the weightage of this type of the numbering system? What the numbers we will get in the decimal numbering system? See dear students, in the decimal numbering system, the radix is 10 or base is 10. The 10 values, base 10 values. Then total number of the numbers in the decimal numbering system, that are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Count all the number from 0 to 9. You will get at the 10 digit values, maximum 10 digit values, 0 to 9, so 10. So now we have a chance to construct a number with the help of the radix 10. How? With the which base we are telling? Because we have an example. Now I will consider one example to demonstrate you how one number, that is base 10 values, are bifurcated and how it will be combined. So for that I will consider one best example. See dear students, example 675. This is a base 10 value, assume. Now I want to extract this base 10 value with this particular, how the number systems are radix, it's 10. I will show you one best example. So count the numbers dear students from right to left, from 0 to what the numbers we will get. So consider 5 has its a number weight, that is a 0. 1, 2. So total weightage of the particular these 3 digit is 0, 1, 2. Okay, the value of the 6 is 2, the value of the 7 is 1, the value of the 5 is 0, sorry. Then how to calculate this one? See here. 0, 1, 2. 6 into 10 to the power of 2. 6 into 10 to the power of 2. You know the calculation. See here, 10 to the power of 2 means 10 into 10, 100. 100 into 6, 600. Correct? So, I will write once again. For the 10 to the power of 2 means that is 100. That is equal to the value of 6 into 100, that is 600. Getting? Because here the maximum weightage of the 6 from the 0 to 9, if I want to calculate, the maximum weightage is 0, 1, 2. The value of the 6 weightage is 2. Hence, I will consider 6 into 10 to the power of 2, that is equals to 6 into 10 to the power of 2 means 100. So, 6 into 100, 600. Like that, coming to the next value, that is 7, 0 and 1. See, 7 into 10 to the power of 1. Okay, then 7 into 10 to the power of 1 means the value is 10 into 1 time. So, that is value 10 itself. 10 into 7 or 7 into 10, that is 70. That is 70. Then, if I coming to the last digit like that, that is 5 into 10 to the power of 0. 10 to the power of 0. Like that, if I want to calculate now, so 5 into 10 to the power of 0, you know in mathematics, anything to the power of 0, that is equals to 1. Anything to the power of 0, that is equals to 1. With the help of that one, 5 into 10 to the power of 0 means that is 1. Because anything to the power of 0, see, 10 to the power of 0, that is equals to 1. So, 5 into 1, that is equals to 5. Now, you add all these values. 600 plus 70 plus 5. 675. The maximum weightage 675. So, this is what we called as a decimal numbering system. All these types of the numbering system has its own radix, that is base 10 value. Why we will call this as a base 10 value? Because 0 to 9 we have the weightage. If I coming to add all the 0 to 9 digits in one form, we will get 10 is in a one number. So, hence the radix is 10. If I want to calculate the numbering system like this form, we will calculate the 675. So, after this, if you want to try any other numbers, you can try in your home, take a one number and just bifurcate that one into base 10 values, then you will get the conclusion like this. So, this is what we called as decimal numbering system. Like that, we are having a chance to convert any number into its decimal value. But one thing you should remember, dear students, the values what you are given here, these numbers should be the length of 10 digits, 0 to 9, 10 digits. So, that type of the numbers we have a chance to convert into its decimal form. So, by this example, what we are getting the knowledge, we have a chance to calculate the number in the any type of the numbering system, but we have a chance for the calculation with the help of its radix. See, if 0, 1, 2 by the radix numbering system, yes, we will get to one types of the number and we have a chance for the conclusion. Like that, in computer also we have a memory. These types of the decimal numbering system having a chance to convert binary numbers because computers will understand only one type of the language, dear students. That type of the language, that is a binary language. So in the next part we will coming to know what is binary numbering system, how we will calculate the binary numbering system. So after a decimal numbering system, dear students, now we have to going to one more second type of the positional numbering system, that is binary numbering system. So in the binary numbering system, how we will classify? See, just you reimagine that how the decimal numbers are calculated with the help of the radix 10. Like that, binary in the name itself, that is telling its weightage. By means 2. So directional, okay? So binary 2 digit. So what are all the 2 digit that we will choose for the binary numbering system? That is the most important thing, dear students. As I said earlier, computer will understand only one type of the language, that is what we called as binary language, as I said earlier. Yes, now we are coming to know what is the binary numbering system, how we will call the radix is 2, and also what are all the 2 numbers we are using, 0 and 1, and how we have a chance to calculate with the binary numbering system, that is what we called as 0 and 1 are the 2 binary numbering system. With the help of these numbers, yes, we have a chance to calculate the numbering system for any types of the numbers. Either it may be a positive number, see, this is a positive number, or the negative numbers. Or why we will call the negative numbers? After the decimal, we have, if any numbers are there, we will consider that as the negative numbers. Like that, fractional numbers also we have a chance to calculate. So then directly I will show you one best example how to calculate the binary numbering system has its base radix 2. So for that example, if I want to calculate the binary digits in the form, see here, example, now I am considering binary number. It is a one type of the binary numbering system. Here we have the fraction. So 11011.101 is in a one type of the binary number. Now I will show you how to get its decimal value with the help of this binary digit. See here, this is a binary digit. Now I want to convert that binary digit into its decimal value. What's its decimal value? Okay, see here. Now I will take like that as in decimal numbering system. Same method I am using for the binary numbering system also. Consider that. See here, by the decimal I will consider the numbers are starting from 0. So 0, 1, 2, 3 and 4. So hence before decimal, here we are getting maximum 5 digits, right? 0 to 4, so 5 digits. But as its radix is 2, 0, 1, 2, 3, 4. Now I will take a column 2 to the power of 4 is in a one number. Okay? Like that, 0, 1, 2, 3, 2 to the power of 3. 2 to the power of 2, 2 to the power of 1, like that 2 to the power of 0. So before decimal, what all the 5 digits are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The values of the bits we will having a chance to fill. Like that, after decimal, what all the numbers are there? 1, 2, 3. See here already 0 is over. So after decimal, now I will consider these decimal numbers by its negative value. Hence here 2 to the power of minus 1. 2 to the power of minus 2. Like that 2 to the power of minus 3. See, this is a normal weightage. How we will give the one conversion of any binary number into its decimal value. Just fill, see in the second column, second row, just you fill the values what we are given in the example. See here, first digit, from the decimal you are calculate 0, 1, 2, 3, 4. Fourth digit is 1, 1, 0, 1, 1.101. This is the maximum numbers how you filled with this example. Now we have a chance to getting its value, decimal value, with the help of the a particular binary numbering system, that is what we called as 0 and 1 numbering system. See here now, 2 to the power of 4. What is the 2 to the power of 4 value? So 2 to the power of 4, 2 into 2 into 2 into 2, like that. 2 to the power of 4 value, 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. Then the value of this box is 16. Correct? The value of this box is 16. Like that, 2 to the power of 3 means 8. Like that, 2 to the power of 2 means that is 4. Like that, 2 to the power of 1 means that is 2. 2 into 1. So 2, 2 into 2, 4, 2 into 2 into 2, 8, 2 into 2 into 2 into 2, 4 times, that is 16. 16, 8, 4, 2. By seeing these numbers, what you will get in your mind, all these numbers are multiples of 2. Isn't it or not? These numbers are multiples of 2. 2, 4, 8, 16, if it is a 5 digit, more than 5 digit, 32, 64, 128, 256, like that the numbering systems are moves on. Okay, then what is the value of 2 to the power of minus 1? 2 to the power of minus 1, I will directly here, 2 to the power of 0 means 1, I will write, because you know anything x to the power of 0, anything to the power of 0, that is 1, 2 to the power of 0 is also 1, hence 2 to the power of 1 is 1. Then, now I will consider 2 to the power of minus 1. What is the value of 2 to the power of minus 1? See here how to calculate 2 to the power of minus 1. 2 to the power of minus 1 is equals to, okay, that will be 1 divided by 2. Okay, 1 divided by 2 means that is 0.5 of 0.5. So the value of 2 to the power of minus 1 is 0.5. Okay, that means 2 to the power of minus 1 means 1 divided by 2 to the power of 1. Okay, so 2 to the power of 1 means 2. So 1 divided by 2, 0.5. Like that, 2 to the power of minus 2 means 2 to the power of, because how we will coming to the, in mathematics you have a formula like this. X to the power of minus n is equals to 1 over x to the power of n. So this will be one formula to calculate the value of the fractional numbering system, dear students. So with the help of this formula, now I will calculate what is the value of 2 to the power of minus 2. See here, 2 to the power of minus 2 is 1 divided by 2 to the power of 2. 1 divided by 2 to the power of 2 means 2 to the power of 2 means 2 into 2, 1 divided by 4. Well, then what is the value of 1 divided by 4? That is 0.25. Off of that 0.5 value, so then you will get the 0.25. 0.25 will be the value for 1 divided by 4. Like that, 2 to the power of minus 3. See here, here itself I will write 2 to the power of minus 3. You may not getting. So here I will show you. 2 to the power of minus 3 is equals to 1 divided by 2 to the power of 3 plus 3. So 1 divided by 2 to the power of 3 means, you know already 2 to the power of 3 means 2 into 2 into 2. So 4 into 2, 8. So 1 divided by 8. Then what is the value of 1 divided by 8? 0.125. 0.125. The value of the 2 to the power of minus 3 is 0.125. Clear, dear students? With the help of this formula, see, once again I will show you how you will getting 2 to the power of minus 3 is equals to 0.125, because we have a formula for mathematics, that is x to the power of minus n is equals to 1 divided by x to the power of n. So with the help of this formula, we have a chance to calculate the fractional values of the binary numbering system. So this is the basic knowledge how we to calculate the fraction numbers in the binary system. Now just you multiply with this numbering system, then you will get the a particular decimal value. See here the 16 into 1, the value of this particular binary number is 16. So 1 is there, then the value is, that is 16 plus, okay. Then what is the value of this one? 8 into 1, then that is 8 plus 4 into 0. Here anyhow the value is 4. 2 to the power of 2 means the 4. But the binary digit is 0. Multiply that 4 into 0, that is 0 only. Like that, 2 to the power of 1, the value is 2. Okay, 1 into 2, 2. So 2 into 1, so that is 2 only. Okay, like that, if you calculated before decimal, the value is this much, and after decimal, now I will calculate this one. After decimal, 0.5 into 1, okay, that is 0.5 plus 0.25 into 0, that is 0 only. Then 0.125 into 1, that is 0.125. Now you add all the binary numbers, what the decimal conversions are there. 16 plus 8, okay, 16 plus 8 plus 2. So here 8 plus 2, 10, 10 plus 16, that is 26.0.5 plus 0.125. What's the value? Okay, 0.5 plus 0.125. So the value is 0.625. Okay, the value is 0.625 by adding these two numbers. Then now we are combining these two value by removing this fraction, that is 26.625. This is the final value of that binary number, but it is one decimal number. Then maximum weightage of that particular value, that is now like this, we were getting 26.625 is a value for that a particular binary value. This is the method how the binary numbers are converted into its decimal number with this procedure. So follow this binary numbers. You in your home, you practice the binary numbers, consider any other binary numbers and convert with the help of this type of the process. Then you will get one clear idea how to calculate the binary numbering system, dear students. After binary numbering system, now we are going for the third type of the numbering system, that is what we called as octal number system in the next session, dear students. Thank you.